Hello interwebs, welcome to Let's Fix Computers. I've got a Lenovo Yoga 530 here, which apparently doesn't turn on, no power. This one came in earlier on today. I'm doing just a quick preliminary check to see if it's viable for repair. Let's see. First thing I'm going to do, I'm just going to plug the charger in here, and we're just going to see what the charge light does. So let's just plug that in. And nothing happened whatsoever. There was no light, there was no flash, absolutely nothing. Fair enough. Okay, so in that case, let's get that back cover off and we'll take a look inside. So these look like T5s. Yeah, T5 screws on the bottom. And bottom cover putting up a slight bit of a fight to come off. I'm going to have to open it up and pry it. There we go. Okay, let's take a look. Charger jack is on the right hand side. Single piece motherboard, so we don't have any advantages with an I/O board or anything we can replace. There's a cover here over the SSD. Right, so I'm going to disconnect the battery first of all. Is that a locking connector? I don't think it is, so I'm just going to pull that out by my fingernails. That's very difficult to remove. Can I poke it out with a plastic pointer? Ooh, there we go. That was very awkward. Probably would have been easier to unscrew the battery and then be able to pull it out as a unit. Doesn't matter. Right, so let's do some basic confidence tests now. So I want to know how far into the laptop power is getting. Oh, let's remove this shield as well. That's going to be over the RAM. Single RAM module, fine. Okay. So yes, let's plug that in and we'll see firstly if anything has changed with having the battery disconnected, and B, how far the power is getting. So charger is plugged in. Again, there's no light there at all, no signs of life. So set the multimeter into voltage mode and let's do some probing and see if there's any power here. I think this is going to be a motherboard failure. Which means we're going to have to take it all apart and get in there and see if we can do some board repair on this, but we'll see. Yeah, so there's 20 volts coming out of the back of the jack and going into the motherboard. So there is power getting through here and into the motherboard. That is what we have now discovered. So it's not an issue with the jack, although we'll confirm that when we get deeper into the laptop, but so far it doesn't look that way. I'm going to just do a closer visual inspection with my eyeballs. No, I can't see any issues there. So, yeah, motherboard out time. So I'm going to switch down to a #1 Phillips, and we're going to take out... I'm going to take this SSD out because that's got customer data on it. And obviously our secondary objective here is to preserve customer data. So let's disconnect that. There's quite a lot of stuff underneath the SSD actually as well. So that was worth taking off just for inspection. There's power stuff going on under there. That's interesting, maybe. So let's take the battery out. And then we're going to take the motherboard out and we'll see if we can see anything interesting on the other side of the motherboard. This empty fan housing is for the slightly higher end models that would have had discrete graphics. You can see there's some unpopulated space on the board where you could put a graphics card, and if the graphics card is fitted, it would have had a different cooler, probably a dual heat pipe design that went across to an extra fan over here. But this one doesn't have it, so they've just put in a blanking bit of plastic there. I'm not sure if this fan needs to come out. Yes, it does, because it's covering the motherboard. Now, to get this hinge open, I'm just going to get an expendable screwdriver and put it in one of the screw holes and then just use that as leverage. And we've got to be a little bit careful just because we don't want to break anything open. And I think that's enough. It looks like we're coming out. Nope, those screws on the actual charger jack need to come out too. There we go. Just going to relax that hinge. And we'll put the body to one side so we can take a look at the motherboard. Okay, so if we turn the motherboard over, there's nothing to see there. Okay, that's very disappointing. Okay, is there anything under this shielding? This might be waterproofing. Oh, there's nothing to see there at all. Well, okay. Well, I mean, I can see some of the traces on the board. So we can see that the main power input here starts here and it goes across. Looks like it goes across through here and down to there. So that comes up around here. So this is where all the action is going on. That's where the input is coming into. Then it goes through what looks like a current sense resistor into this section here. And it also comes down here to this area. So these are going to be our secondary power supplies. So we need to trace the power around there then. Okay, this thing didn't really need to come out the laptop. However, we do have more access. Let's plug it in and we'll see if we get any more information. This is a very thin and flexible board, so I don't really like having these out there on the bench, but There's our 20 volts at the input. It also appears at this fuse, whatever that is doing. That's interesting, actually. It goes through to the other side of the board as we just traced, but it also goes through this fuse up to the top of this section. I wonder what that is all about. It might be that it's jumping across here so it can power stuff down here, and this is all independent. Have we got power over here? Apparently not. Okay, so it goes up to the input inductors here and into this MOSFET. Then is there anything coming out of the MOSFET? There is not. Okay, let's try and trace it on the other side of the board because it looks like we're coming into the laptop and then stopping dead there. And again, just to confirm, we should find that there's no power on any of these power supplies. No. Nothing doing anywhere else. So there's the back side of the pin. Okay, I'm an idiot. I've misread the board here. It looked like it was jumping across and going down here, whereas it doesn't. There are vias there and vias there, but there's actually separation across here. There is no bridge on either side. So the reason why these vias are here, it just stitches the bottom part of the board to the top. So this is nothing. That doesn't mean anything. What's actually going on there, that bit that I pointed out, where I said, oh, it's going off down here, what that is actually doing is there are vias here, and on the other side, that goes up to here and comes up here, and it goes into the display connector. So on the output here, our B+ rail, so the main power rail in the laptop, just goes straight up into the display connector. So that's then providing 20 volts to the LCD backlight. So that's what was going on there. So the bit that I pointed out earlier on, that's nothing. So the bit we're interested in is just here. It comes in through the laptop, through a fuse, through an inductor, and into the MOSFET. And that is where it is stopping. So this MOSFET is either not open or it's broken or something like that. So let's check for short circuits. So I'll unplug it again. And we're going to go into continuity mode. And we're going to look for short circuits. So nothing there. Ground check. Nothing there. Nothing there. Aha! Okay, so the main power rail in the laptop is shorted to ground. That is why this guy is not turning on, because there is a short circuit inside the laptop. And so this guy is not turning on because it's detecting the short circuit and going, there's a problem, cut the power. So that is why there's no 19 volts getting past this guy, because everything past this guy is shorted. So where does that short circuit start? It's not there. It's on the other side of this guy. So there's two MOSFETs here. There's a high, well, it's not a high side and a low side, but on an inrush limiter, you usually have two MOSFETs. You've got one that's connected to the main input, and then another one that then switches to the output. I'm not 100% certain why. It's just to do with the way that it's to do with isolating faults, I guess. However, the point is, there's no fault up to here. It's from this guy onwards that the fault begins. So, short circuit on the main power rail. So, we found our beeps. So these secondary power supplies, these are going to be generating our secondary rails. So 5 volt, 3.3, 1 volt, and so on and so forth. So are any of those shorted? It would appear not. Okay then. So I assume that if we come back up to here, this is going to be CPU Vcore. So this will be the power supply into the CPU, I would imagine. We should find this. This is probably going to be shorted on both sides. Yeah. Okay, that's not surprising. The CPU is generally shorted when off. So, and the idea of that is that if there's any static or any stray power in the laptop, when the laptop is turned off, it just shunts it straight to ground so the CPU isn't damaged or anything while it's turned off. It's in a sort of storage mode, as it were. So that's fine, that's to be expected. So we've got some more input inductors from the battery there. Is that shorted? No. Fine. Okay. Well, I think we're going to go straight to a voltage injection here, because the main power rail is going to pop up all over the place on this laptop. So we're going to be here all day trying to find that. So the fastest way to find this is to solder some jumper wires onto the motherboard, and we're going to inject power using a DC power supply, and we're just going to let the short burn and see what heats up on the laptop. And if we're lucky, it won't be the CPU. Right, so to inject power, we need to wire in two mod wires. So I've got these two here. These are both fairly beefy wires that I've got. However, these are wildly overkill for what we're doing. And I need that because I want to make sure that we're not losing any power in the wires themselves, and all the power that we inject sinks into the board. So I need to connect both these up. My ground, so the black wire, I can connect this to any ground on the motherboard. So the obvious choice for this will be a screw hole. All this area here where you can see all the copper plating, that's all ground. So I'm going to solder directly onto the edge there. Then afterwards I can clean that up to make sure that the screw hole isn't blocked. Then my power, so our short circuit appears along this power rail here. And we've got these 2 points here, which are probably test points. And those are both on the power rail and they're both shorted. Once again, if I just quickly turn on my multimeter. So if we touch the black probe to ground up here in the corner, and I touch those with the red probe, we can see that there's a dead short circuit between that ground plane and this power plane. And there should not be a short circuit there because it's a power plane. So I can solder my mod wire onto one of those jumpers there, and I can inject power at that point. So let's warm up the soldering iron and we'll get those mod wires hooked up. Okay, I'm going to add just a touch of flux onto there just to make my life a little bit easier, and we'll put a little bit on the screw hole as well. And let's get these guys tinned up. The screw hole will put up a bit of a fight because it's a big old ground plane, so I'll actually have to get heat into it before the solder will stick. There we go. And this guy. There we go, we've got a solder blob on that as well. Alright, and here comes the mod cable. There we go. So I've got that guy soldered onto the board and it's clearing everything else so it's not going to short out against any other points. And ground. There we go. That's him attached. Now we have two wires that have a dead short circuit between them. So this is the short circuit that we need to find. And the short circuit is somewhere in the board. So I'm also just going to remove anything else from the board that doesn't need to be here while I do this. Just for security. So I'll take out the memory module. Not that that particularly matters, but just in case. And I'm going to take off the CPU heatsink as well, because that will make it easier for me to detect if the CPU is shorted. Because if the CPU starts heating up, then that's our problem. However, I won't be able to tell while it has this heatsink on it, because that will probably just heatsink away any heat that's coming out of the CPU, which is what it's supposed to do. So we'll take this guy off, and then if the CPU is actually causing our short circuit, we'll find it. Thermal paste is absolutely spent on that. Worth replacing anyway. Alright, now comes the scary bit. So, the power rail is the main power circuit in the laptop, and because it's going directly to the charger, it will normally be carrying 20 volts. So it's a big, beefy, high power rail. Theoretically, we can just put 20 volts into this. However, that's a little bit scary and I don't like doing it. So I'm going to set my power supply to 5 volts and 1 amp. So it's going to sink 1 amp at 5 volts into this board, and we're going to see if anything warms up. I'm not expecting to find anything at that power level. However, we start low and we build it up. Okay, and that has gone to a dead short, as it should do. So now comes the touchy-feely bit. So now I've got to basically just touch up the board, and I'm looking for anything that is hot, because the board should be dead cold, but if anything is hot, that means it's passing current, and that means that it is the cause of our short circuit. We've got to find the path that this power is taking from here to here. We've got to find what component it's going through to get there. So the guys that I'm keeping my eye on is any large flat thing, so you know, these MOSFETs, that kind of thing, and capacitors, so these big tantalum capacitors or the small little brown ceramic boys. I'm just putting my finger on any of those, looking for anything that is hot to the touch. And I'm not feeling anything at the moment, and I wouldn't expect to. So let's turn the power up. Let's go up to an amp. Nothing happening yet. Okay, let's give it 1.5. I think there's something going on over here. Might be my imagination, because there's nothing there. The board just feels over ambient there. Nope, I'm going to give it more. 2 amps. I'm going to very carefully turn the board over and check the other side. Ah, there is something over here. Oh yeah, there's definitely heat there. I think it's that guy. There is definitely warmth right there. I think it's that guy there. I'm going to take a pot shot at that. So I've just disconnecting my crocodile clips. Turn off the power supply just so we don't short that out against anything. So we haven't got a smoking gun yet. I could turn the power up more and drip a little bit of alcohol onto that just to see if the alcohol starts boiling away around it. However, that is a capacitor and it feels warm. So that is around this area here. I'm just going to take a pot shot and see if I get lucky. So I'm going to warm up my hot air station now, and we're going to see if I do get lucky. Okay, so I've got my hot air station on maximum air, 400 degrees, and I'm just going to blow over the general area just to gently heat up the board. I'm going to angle in this direction to try and stay away from the CPU area as well, because we don't want to put any heat on the CPU if we can help it. That's just not a good idea. Okay, and let's go in for the flow. There we go. In and out as quickly as possible. Now we put our multimeter back into continuity mode and we see if I was right. Beat mode activates, and... oh! That capacitor is not beeping. That would have been amazing. Yeah, the short circuit is still there. Right, are we going to take off that one as well? I think I should. I think I'm going to. If this doesn't work, we're going to carry on injecting power. We're close, but I'm not going to grasp at straws. Shit. Nope. I'm miles off the mark. That's not it. Okay, I'm going to stick those two capacitors to one side for one moment. And we're going to turn on the power supply again. I've got to wait for the board to cool down first. The board is hot where I've been soldering on it. I'm going to wait for the board to cool down before I power it all back up again. Okay, right, the board has cooled, which didn't take long because it's a very thin board. So, power. Right, and once again we've gone down to a 2 amp short. So, I'm going to take it up to 2.5. And we're going to go straight in. Once again, a warm spot has appeared. around this area. So I'm just going to let that settle for a bit. In fact, I'm going to take that up to 3 amps. No, there's nothing going on around there. It's not even enough to dry out the alcohol at the moment. 3.5 amps. We're getting high now. I'm going to check around the rest of the board just in case I'm getting sidetracked. Definitely there. This area is definitely warmer than the rest of the board is. I'm going to check the bottom of the board. Felt like something just burnt the tip of my finger then. There's nothing over here though. Ooh. There's you. Oof. Ow. There's you. God. It's that. Got it. Disconnecting because phone. If we zoom into this guy, you can actually see that it looks visibly fatigued. Shaky cam. You can actually see that it looks visibly fatigued. Compared to the one next to it, that guy looks fine. That guy doesn't look fine. So I'm kind of annoyed because I did actually spot some faint markings on it when I was taking off the dudes from here. That's where I took off the other one. So I was really close, just not quite there. It was just sinking power through there. And yeah, doesn't matter. At any rate, that guy's burning up. So that is definitely our issue. I'm going to rip that guy off the board. And then I'm pretty certain our short circuit is going to disappear. So let's get the hot air back on. And we'll take that dude off. Okay, multimeter in beep mode. So firstly, our little capacitor is in a dead short, and our motherboard is now no longer shorted. Done and done. So now I'm going to solder on the ones that I removed. So I'm going to get out my, I'm going to get out, no, I can use the ghetto soldering iron. Normally I would use a better soldering iron for actually reworking the board. However, it's a couple of capacitors, it'll be fine. Just heat the board. Okay, that's soldering iron, get out of here. Right. I have no heat on that pad at the moment. This is ridiculous. I'm getting out my good soldering iron. And just straight away, those pads are now tinned. So... Right, that was the biggest hash up of soldering I've done in quite a long time. However, we should find that we are still no longer shorted. So, again, ground test, beep, no beep. And on one side of this, it should be ground. And on the other side, it is not. There we go. And the reason for that is that this is a buck converter, so this is a secondary power supply. There is a high side MOSFET and a low side MOSFET. the high side is switching in higher voltage, so 20 volts from the charger, and that is switching it through here, through this inductor, into whatever this is powering, one of the parts of the chip this will be. And then the low side MOSFET, that stabilizes it, so when this switch is off, this switches in and drags the voltage down. So if you search my channel for buck converters, I have done videos on how those work. So that is what is going on there. And in this instance, on the other side of the board here, we had that guy there. So that was going into, that was on this one here, which is part of CPU Vcore. So these capacitors here will be part of stabilization. They help keep the circuit stable. They help reduce unwanted frequencies and things like that. However, the most important thing is that not all of them are actually needed. These things are over-engineered, designed to pass emissions testing, and it doesn't need to pass those emissions tests to work. And when I say emissions, I don't mean it's not going to make people, it's not going to give people headaches by emitting radiation and all of that. We're talking like amounts that require very, very strong equipment to sense. So nothing that we're worried about, basically. So I'm just going to toothbrush the alcohol off the toothbrush the flux off the back of the board there. And I'll just use a little bit of alcohol down there. And then we can remove our mod wires and we can try and power this thing up. And at this point, we've no reason to believe that it won't work. So I'm going to turn on the poor man's soldering iron. No, just use the decent one. Okay, that's our positive leg removed. And this guy. Now I'm just going to use the solder wick to remove the solder blob that I've left behind. There we go. Now it's flat. Okay. Oh, and just in case anyone's curious, because I always forget, for reference, the good soldering iron I pulled out is a TS100. Very affordable, high quality precision soldering iron. And this is the TSKU knife edge tip. And as you can see, as soon as I got this guy out, everything was easy. Very good soldering iron for hobbyists and professionals alike. Right, so I need to remove the last of this thermal paste, so let's get some alcohol onto that just to duff that stuff up. And I'm going to grab some precision loo roll. And I'll do the same thing with the cooler. You can remove thermal paste without alcohol. Alcohol just makes it easier. You can use glass cleaner as a poor man's substitute for alcohol as well. So like Windex or something like that. And for cleaning up your hands of thermal paste, good old dish soap is all you need. There we go. That's all cleaned up. So now we'll put some fresh thermal paste on and get that cooler refitted. Where did that go? That was on like that, wasn't it? There we go. All right. This is Arctic MX4 thermal compound, which is just a good, affordable performance thermal paste. And we only need just a little bit on each. Just going to nudge that stuff over. We got way too much there, but that's fine. Too much is better than too little. Because all the excess is just going to smush out the sides anyway. And I'm going to screw these screws up in the wrong order because I'm hectic. And memory module back in. Reconnect the thermal, reconnect the cooling fan before I forget. And I could even put the tin shields back on now, I think. And what I'm hoping is that in a moment, we should have enough of this put back together again that we can plug in the power adapter and get a power light on it, which will just confirm that everything is hunky-dory. There we go, that's good enough for me. Right, yeah, let's do it. So here comes the charger. I'll turn the board over just so you can see the light, which will appear here. Okay, it flashed. And the board twitched. I'm not sure exactly what that meant, so I'm just going to double check for short circuits again, because I don't like flashes. Oh no, there's mega ohms across there, that's fine. Yeah. We need to get this back in the laptop before we can really give it a fair test. It's going to be upset because it's not connected up properly. And I'm just going to give these hinge screws just a little bit more of a bite than I normally would, because you don't want those to come loose. Right, that's the display connected. And I'm going to plug in everything else. And we should get a picture on the screen. Alright. I haven't connected the wireless card or the SSD, but we don't need those for it to turn on. We might... I'll be happier when I see that it charges the battery, but we'll come back to that. Okay, right. Charger connected. The display has initialized. The cooling fan has spun up and off. Is that power cycling? I think it is. Ooh. Nope, there we go. Phew. Oh, for a moment, I thought we weren't there. Default boot drive missing or boot failed. That's fine. There's no SSD. So it looked like it did a couple of power cycles just to complain about stuff not being there. That's fine. Let's get the rest of it plugged in. Whew. We are 99% done. Not gonna lie, I really thought it wasn't gonna start then. I was proper scared for a moment. I mean, obviously that would have meant that we just had something else to look for. Although, you know, yeah. The game we play. Oh, heck. Oh, I didn't put the shielding back on the bottom. That's got to go on. That's a recipe for disaster, not putting this back on. That was a big mistake, me not putting it on straight away. Okay, we're going to go into fast forward mode while I do all of this bit, because this is literally just fitting now. So, here we go. put this one on with the Lenovo warranty sticker on top of it and pretend we were never here. This thing's about 30 months old, apparently. I'm going to loose fit the back cover. I'll just click that down, but I'm not going to screw it on quite yet. I want to see it start. Right, we now have a solid light on the charger, and if I push the power button, it'll probably stutter a bit coming on because the battery was disconnected again. Nope, we're okay. There we go. And we're booting. That's that. Hello there.